Thanks. Thanks so much for the invitation. I wish I was with you live and in person in Houghton. I live in Ohio. I make it up to campus at least once every semester, and was up there recently and witnessed a good amount of snow that's still hanging around. So never fear, spring is coming. I saw a woodchuck standing in a field looking kind of bewildered the other day, but they're popping out of their dormancy. So let me jump into the topic of the day, and that is all about, well, I guess you could say it's about planting trees, but this is step number one, and it's really the most important step if we want to plant trees, and that is making sure that we have the right tree in the right place. So just a little sidebar here. If you have access to the Washington Post, back a couple of days ago, they published this story about making friends with trees. And I'm not sure how they came about it, but they became aware of one of the assignments that I make for my Michigan Tech students, and that is to interview a tree. And so the story of interviewing a tree is part of this article. So if you get a chance, check out the Washington Post. It's kind of a fun article about making friendships with trees. So we have this relationship with trees, and of course, when I was working primarily in traditional forestry, that relationship was growing trees so that we could cut them down and make something out of them, which was fine and honorable, and certainly we need trees for that, for their wood. And being a woodworker, I certainly appreciate, a nice fine piece of oak. But for us that live in cities, we really hope to have more of a symbiotic relationship where both parties, trees and humans, are benefiting. So there's this whole list of benefits that trees provide for us. And we can look at those in terms of environmental, economic, and social benefits. The environmental ones are things like oxygen production and reduction of air pollutants and reduced stormwater runoff and carbon sequestration and beneficial shade and beneficial wind shielding and all this list of environmental benefits that we tend to call ecosystem services. But then there are economic benefits for us as well as has been shown. If you have a well-maintained shade tree in your front yard or backyard of your residential property, chances are pretty good that your property will be worth more money because of the presence of that tree. And then there's this long list of social benefits that can be summed up that access to nature for us humans is good for our health. It's good for our physical health. It's good for our emotional health. Dare I say, it may be good for our spiritual health as well. So we can perhaps maximize the benefits that we get from trees by selecting the right trees that we plant and making sure that we're putting the right tree in the right place. The flip side of the coin is that there are costs associated with having trees around people. The cost of simply buying the trees and the labor that goes into it, but then the maintenance that goes along with caring for the trees throughout their lives, pruning, watering, fertilizing if necessary, pesticide application if necessary, and ultimately the removal of the tree. And hopefully, we're not removing sickly trees that were in the wrong place. But then there's these social costs that if you have trees with weak wood and they are not very vigorous, then chances are they're going to break apart. And when you have chunks of wood falling on people and causing property damage, that's a huge cost. And we can minimize those costs once again by having the right tree in the right place. So that's what we're going to focus on for the next few minutes. A few examples of wrong tree in wrong place. These are trees that were planted in Los Angeles. Somebody had a noble idea. We need more trees in our cities so that we have these benefits. But um, they perhaps did some planning in selecting the hardware, the perforated grate so that the roots can get to some water and oxygen, although it's kind of a feeble attempt. But then they put the wrong species, and within a few years, these trees have outgrown their spaces. We can do better than this. We can have the right trees in places even like Los Angeles, but we have to think about it. More wrong tree, wrong place. Noble idea. Let's plant trees, but then they put a tree that quickly outgrows the kind of feeble attempt at giving some oxygen and water to the roots. And then you've got trees that have surface roots, and you can have tripping hazards and just the cost of repairing the pavement. But if you have people that are tripping on your pavement and injuring themselves, you're going to have lawsuits, and that costs a lot of money. And then, of course, we have trees that are in conflict with overhead utility lines. Big cost at just don't do this. Right tree in the right place. Here we have a community, this happens to be in Columbus, Ohio, where they have a beautiful streetscape. They've got properly sized plants in properly sized spaces. And this is what you get when you have the right tree in the right place. You can wind up with a really attractive streetscape. Of course, if we're going to talk about Columbus, Ohio, we better talk about Ann Arbor, Michigan at the same time. Here's a magnificent American elm that has been treated numerous times to protect it from Dutch elm disease. But it's interesting how these trees complement the architecture. That, without the trees, the architecture just looks like buildings. But when you put these two together, you've got a living organism next to a building that was created by humans, and you've got an interesting landscape. This is an entry to a botanical garden, and you don't want a lot of conflict between the traffic coming in or going out. So in this case, they've selected a columnar variety of sweet gum. So they've got a row of trees, and that's as big as they're going to get. Right tree, right place. And then when we look at our neighborhoods, when you provide shade to the buildings, it's not only visually attractive, but it also saves on air conditioning costs and even heating costs in the wintertime. And since so many of these environmental benefits are are associated with leaf area, in other words, the more leaves you have in a tree, the more pollution is absorbed. The more leaves you have on a tree, more photosynthesis, more oxygen is produced. The more leaves you have, the more carbon sequestration you have. The more leaves you have, the more stormwater you intercept before it winds up in the sewer system. So wherever we can, we would like to have big trees that have sufficient space to allow their full mature growth. Right tree in the right place if you can do it. Um, this is Central Park in New York. It's a beautiful place. But when you have that many trees around that many people, you have to really make sure, number one, you're taking care of the trees, and number two, you've got the right tree in the right place. This is a view of a street in a community just outside of Chicago. Unfortunately, all of these trees, virtually all of the trees that you see are ash trees. And, 20, 30 years ago, this street was beautiful with all of these trees and the shade they provided and the habitat they provided for songbirds. But then the emerald ash borer came along, and this is what's left. And these trees are dead and have to be removed. And within a period of a couple of years, we went from beautiful full landscapes to clear cuts. And the message that we have tried to learn over and over again and haven't quite gotten it yet is we need to increase our species diversity. We saw what happened with chestnut blight. We saw what happened with Dutch elm disease. Now we're living with the emerald ash borer problem. If something comes along and takes out all of our maple trees, we are going to be in some really deep trouble. So it's not only right tree in the right place, but it's adding diversity to your tree population. So how are we going to achieve this? How are we going to get the right tree in the right place? We all want to plant trees. It's great. Arbor Day is coming up. Many of the elementary schools will send home a little Dixie cup with a tiny little seedling in it. And of course, our children come to us and they hand us the Dixie cup and they say, "Can you please plant my tree for me?" And we don't recognize that it's an Eastern white pine seedling in the Dixie cup, and then we plant it, 5 feet away from the edge of the house, and then stand back. It's like Jack and the Beanstalk. You've got a tree that wants to be over 100 feet tall. So we'll get to proper spacing in a minute, but let's start with climate first. And first thing we want to look at in the site where we're considering planting trees is what hardiness zone are we in? And of course, most of you understand hardiness zone. It's the average annual extreme minimum temperature. It's how cold we get. And for many plants, that's the limiting factor is how cold it gets. And so you can see on the hardiness zone map, all the different colors are all the different climate zones. We can look at Michigan and see that there's a pretty wide range of climate zones, even in our own state. So if you're in the Western Upper Peninsula, you might be in zone 4A and experience -30 to -25 degrees as the minimum. In Houghton, we've got the benefit of the temperature moderation of Lake Superior. So we're currently in 5B. That's probably going to change. If you're down in the Detroit area, you're up to zone 6B. And so trees that might be able to survive in Detroit and Ann Arbor might not be able to survive in Houghton or certainly places like Ironwood. So know what hardiness zone you are in and get plants that are happy in those climates. So I went to a local nursery and was looking at their trees. And of course, when you go to a nursery, most of the plants have some type of a tag that identifies what species it is. And hopefully it tells you a little bit more about that species. So on the left, this is a tag that was on a birch tree, a species of birch. And at the bottom of the tag, where you see the little red arrow, it lists the cold hardiness. It tells you right there that this plant, this tree, can survive in places that have temperatures as low as -30 to -25 degrees Fahrenheit. Oh, well, that's useful to know because we could plant this in Houghton and it would more than likely do pretty good. On the other hand, the tree that was just a few feet away from it had this tag on it, and all it says where the little red arrow is Z 6 to 9. And they don't give you any indication of what Z means. It means zone, hardiness zone. And they don't tell you what 6 to 9 is. And so this tree is in a nursery in Ohio and is at the very northern edge of its range. You could plant this down in Georgia and it would be happy, but you couldn't plant it in Detroit or certainly Houghton. And so it would be good if this tag told us a little bit more. So sometimes when we look at plants in nurseries, we need to do a little bit of Sherlock Holmes work and understand what it is that the tag is telling us. So we've got these hardiness zones that are good for, fairly large regions. But when we get into cities, there's a lot of variation, and we have these microclimates. So in places like Chicago or New York or Detroit, you got this building here that reflects a lot of sunlight, and maybe that's good for the trees because they're shaded by other buildings. But in the heat of the summer, that could mean that they're getting burnt by so much reflected sunlight. And then off on the right, you've got this lonely little plant that's out in the middle of a mall parking lot, and it's just going to get burnt up because of the reflected heat from all of that asphalt. So your site could be a lot different than what the microclimate in general tells you. So be aware of where you are and where you're considering planting the tree. I've noticed on the Michigan Tech campus, there's some really interesting trees that are on campus that you wouldn't necessarily expect to find there. Right by the library, there's a Kentucky coffee tree, which is really cool. Not something you're going to see growing in the woods in the Keweenaw. There's a tulip poplar that's right by the entrance of the hockey rink. Not something that is within the native range of tulip tree, but they're doing pretty good, and so your microclimate might be a little bit more favorable. So we know something a little bit about the climate. What about the soils? This is it could be really easy. Picking up a handful of soil and running it through your fingers is going to tell you whether you've got a sandy soil or whether you've got um, something with a higher clay content. And then the really important one is pH, um, which we'll get to in a second. If we look at the forest floor, this is what trees have evolved in. And there are multiple layers of soils in a forest soil. And on the top of the soil, you see a lot of this organic material that is slowly being decomposed and reintroduced, recycled back into the soil. And and those nutrients become available to the roots. And the soil is very much the consistency of a sponge. There's solid parts, but there's lots of open pores that the oxygen can get to the roots, the water can get to the roots. And this is what tree roots, plant roots thrive in, this type of soil. In urban areas, a lot of times this is what we see. It's not much in terms of organic material because we tend to rake it up and throw it away or put it in a landfill. Highly compacted rubble, you don't know where the soil came from, a lot of fill material. This is not very conducive for plant root growth. Um, so dig up a shovel full of soil where you're considering planting the tree, and take note of how dense it is. Do you have to jump on the shovel to get it to go into the soil, or can you move your shovel through the soil relatively easily, and that would be a good thing. We have a really big problem in urban areas and even just in residential neighborhoods with soil compaction, where we tend to scrape off what we think of as topsoil that has all of that good organic material. And then we run heavy equipment over the soil before we plant or build our houses. And that soil of what used to be the consistency of a nice sponge becomes the density of a brick. And those roots have a very difficult time working their way through those compacted soils. So knowing something about the density of the soil where you're at is really important. And then we got this this issue of pH. Now, you're not going to be able to pick up a handful of soil and know what the pH is. You're going to have to put a couple of scoops into Ziploc bags and send them to your county extension agency. And chances are they'll be able to give you a pH test for minimal cost, if not free. But most of you are familiar with this pH graph. Basically, every little stripe is a different nutrient that is essential to the growth of plants. The wider the stripe, the more that nutrient is available to the trees. Conversely, as the stripe gets narrow, the nutrient gets locked up in the soil and is no longer available to the roots. So along the x-axis along the bottom, we have pH. As far left is very acidic. And as you work your way from 4 to 7, you get less and less acidic. Once you hit pH 7, it's neutral. And once you get beyond 7, it becomes an alkaline soil. Well, as you can see, a lot of these nutrients are not very available at all in high acidic soils. Iron is there, manganese pretty much is there. And as pH goes up toward neutral, all of these nutrients start to get more and more available. But then iron and manganese start to drop off. And so we look for a sweet spot where most everything is available to the plants. So if you're lucky enough to have soil that's in that range between mildly acidic 6 and neutral of 7, you're doing pretty good. If you're up on the Yellow Dog Plains, north of Marquette and over towards Skawnee, and you got a bunch of beach sand, well, those soils are more acidic. Things like jack pine and aspen can do pretty good there, but things like sugar maple, not so much. And so that's a combination of soil texture, of soil drainage, and soil pH. So for just a little bit of work and not much cost, you can learn about the pH of your soil, and that's a good thing. So this is a two trees in a cemetery. This is actually the cemetery where my parents are buried. And the tree on the left is northern red oak, and it looks like it's doing pretty good. Tree on the right is a pin oak, and it's kind of yellowish, doesn't look to be all that vigorous. So, what's going on here? Why is the red oak doing good? Why is the pin oak struggling? It's all about pH. And as it turns out, the cemetery soil has a pH that's around 7, a little bit higher up into the alkaline area. And when you get into slightly alkaline soils, there's plenty of iron that's in the soil, but it gets locked up to the soil particles. It refuses to dissolve in water. And if it refuses to dissolve in water, then it's no longer available to the roots. So pin oaks tend to need more iron than red oaks. And the pin oak's not getting enough iron, and it's not because the iron's not there, it's because the pH is too high. So if you want to plant rhododendrons and azaleas, and you do, and you see that they're kind of yellowish and they're not doing very well, it's probably because your soils are pushing up toward alkaline. So grab a handful of soil, send it to your extension agency, let them tell you what it is. Okay, so now we know something about the soil. Now we really need to take a look at the planting site in the available space. This is a space in a sidewalk in some city in Germany. And they've dug these holes with the intent of putting a tree in that hole. Does that look like a hole that you would want to live in if you were a tree? It's what? It's maybe 2 feet by 2 feet at most, and it's the density of a cinder block. And so essentially what you have is you'll have a potted plant. the roots will have no chance of breaking out of that area. And so everything that the tree needs, everything that it gets is going to have to come from whatever drizzles into this jail cell, if you will. From Germany to the Bronx in New York, somebody had a noble idea. We really would like to have a tree along our street, but you can't put a large growing species in a space like this. I mean, look at those roots. They have no place to go any further underground, and they're just kind of reaching skyward because that's the only space that is available. Noble idea. Somebody wants a tree in their sidewalk, and they thought enough to put these bricks down to protect the roots. And they thought enough if we use bricks with holes in them, at least the water can get in. I think the people had a noble idea, but it's a tiny little cutout. And then when you look at the tree in its full dimension, it's got no place to go with its roots. It's planted right underneath the utility lines, so it gets hacked and whacked on the branches. It's you want to go up to this tree and hug it and say, "I am so sorry for what we have done to you," right? Um, and I've been known to do that. I don't know that the tree appreciates it anymore, but so what can we do about these highly compacted soils and if we want to have them in places like sidewalks? Well, there's a researcher at Cornell. Her name is Nina Bassick, and she came up with this idea of mixing really coarse gravel that could be compacted to the density that is required to hold up sidewalks, but mix it with highly organic soil. So the organic soil occupies the pores in between the compacted gravel, and the roots can find their way through these big pores, get the nutrients that they need, and still exist in these highly compacted soils. Another thing that you can do in sidewalks is use these things called strata cells. They're heavy plastic. You can stack them on top of one another. You fill them with good organic soil. The sides are perforated so the roots can find their way into these cells and can explore the nutrients and the soil that are available. But the strata cells are strong enough that they can support the pavement. So, what about water? We've talked about climate, we've talked about soil, the planting space. Is it big enough? Water, do we have enough? Do we have too much? In urban areas, it's either feast or famine. So you got a tree out in the parking lot, 9 days out of 10, it's way too dry. It's not getting anything because the water's running off and getting into the sewer before it ever gets to the roots. But on the 10th day, I don't know about you, but we've had just torrential rainfall in Ohio the last week, and everything is flooded. And now the roots are submerged. They got more than enough water, but they don't have access to oxygen in the roots, and now they're suffocating, right? So we need to provide planting spaces where there's enough water, but not too much. One idea is these pervious pavers. They're used mostly in parking spaces. They're dense enough to hold up the weight of vehicles, but they've got holes all the way through so that water and oxygen can get to the roots. Is it a perfect solution? No, but it's better than covering up the roots with asphalt. Okay, so now we know a whole lot about the site that we're going to want to plant the tree. Now we got to look for trees that have matching characteristics. And once again, it starts with, let me back up, the hardiness zone. Is it right for the climate? Then we're going to ask, what's the growth habit, the form? Do we need a really narrow tree, like the one that was in that botanical garden, or do we have enough room for it to spread out? Is there enough room for the branches in the full mature dimensions? But what about the roots? Is there enough space for the roots? And the roots can grow well beyond the drip line of the tree. And then resistance to insects and disease. We probably don't want to be planting a bunch of ash trees, at least anymore. The pH requirements, light requirements, salt tolerance, all of these things that we need to think about as we're narrowing down our list of potential species that will go in, our front yard or our sidewalks. Know what insect pests and pathogens are in your region. Emerald ash borer, of course, is the biggest problem most recently. But then there's Asian longhorn beetle that its favorite genus is Acer, maples. It'll eat almost anything, but it goes for the maples first. And if Asian longhorn beetle gets out, we got a big problem. Hemlock woolly adelgid, spongy moth that used to be called gypsy moth, now referred to as spongy moth. And the most recent one is spotted lanternfly. Its favorite host is tree of heaven, which might not be such a bad thing, but they like grapevines a lot, and so these guys are just decimating the vineyards in New York and other places. Hopefully, it hasn't gotten out to California yet, but if it does, it's a big problem. Then you got things like Dutch elm disease, the diseases. You got oak wilt, which is now becoming a bigger problem. If you're out west, you got sudden oak death. If you like crab apples, that's great, but you want to get a cultivar that is resistant to apple scab and those kind of things. And then avoid those that have weak wood or weak branch attachments, like Callery pear. Callery pear was the darling of trees to be planted a decade ago. And now, 20 years in, we realize that they just explode when you get an early snowfall in the fall or ice in the spring. So we don't plant those anymore. And then we can talk about undesirable fruits. Ginkgo is an awesome tree. It does great in urban areas. It's beautiful in the fall, uh, and really, really durable. It's a great tree. It's one of the oddballs that has separate female and male trees. Most of our trees have both male and female parts on them. Ginkgos have female trees and male trees. The ginkgo females, as expected, are the ones that make the fruits and the seeds. Problem is when the ginkgo fruits ripen, they have a very distinct odor that smells very much like dog poo. And when they get ripe, they get squishy. And when you step on them, it's very much like stepping in a pile of dog poo. So you don't want to plant a female ginkgo tree in an area that has a lot of foot traffic because you'll have stinkiness, and you don't want stinkiness. A little bit about the difference between varieties and cultivars. Varieties are subsets of species that can be found in nature. So, for example, honey locust, when you find it in the forest, usually has huge thorns all over it. It's not a very good tree for planting in your front yard because it's got these massive thorns. Every now and then you'll come across a thornless one, um, and you can take the seeds from a thornless variety, plant them, and you'll get another thornless tree. That's different than a cultivar. A cultivar, let's say you come across a beautiful red maple tree, just blazing red foliage, and you want to plant more like that. And you take the seeds from that tree and you plant them. Some of the seedlings and saplings they grow might have a nice red color. Some of them might not have good color at all. And so if you want to reproduce that particular characteristic, you have to do it vegetatively, which means that you're either going to graft them or root them. You can't grow them from seeds. So a cultivar is a plant that has been vegetatively reproduced through cuttings or grafting. So when you go to a nursery and you see on the tag it says Acer rubrum, that's a red maple. And when you see in single quotations autumn blaze, that is a cultivar that is all of the autumn blaze are genetically the same because they can all be traced back to a single tree. So we're going to look at characteristics like foliage, things like our dogwoods, our a whole bunch of different cultivars. Same thing with crab apples. There's probably 100 different cultivars of crab apples. Pink ones, white ones, purple ones, but a wide range of susceptibility to diseases. So you want to make sure that you get a cultivar of crabapple that is resistant to apple scab and rust. So favorable things, beautiful foliage in the fall, but that, it doesn't end there. It can be interesting foliage in the growing season, like our native tamarack. And then the leaves in the lower left are ginkgo, very unique shaped leaves. They're actually gymnosperms, more closely related to pine and spruce than they are to maple and birch. And in the wintertime, you can get cultivars of crab apples that hold on to their crab apples all winter long and provide some interesting color even during the winter seasons. Red crab apples, yellow, gold. So pick one that you want to have the favorable characteristics. Even bark can be interesting. The cinnamon color of the of Scotch pine, the golden peeling of the yellow birch, all sorts of interesting characteristics from foliage to fruit to bark. And then tree forms. You can get virtually any shape of tree that will fit into your space. And of course, the king of variability is what we know in the Keweenaw as northern white cedar. If you go to a nursery, it's going to be called arborvitae, right? But it's the same species. You can get arborvitae, everything from tall and skinny to ground cover that never gets more than a couple of inches tall. My wife told me that she wanted the tater tots, and there's a cultivar of arborvitae called tater tots. They never get any bigger than a basketball, and so now we have tater tot eastern or northern white cedar planted in our front yard. So be diligent about the form that your tree is going to take when it's mature. Native versus introduced, all things being equal, native are usually favorable to introduce, but then we get into the problem of species diversity. And so we need to have appropriate introduced species if we want to have greater diversity. So you're going to have to do your homework and make sure that you're getting something that is not going to be invasive. An invasive is a introduced species that outcompetes the natives. In many places, Norway maple is considered invasive. There's an awful lot of Norway maples that are planted in Houghton, right? And in some places, they outcompete the native sugar maples and red maples. And then lastly, now you're ready to buy the tree. You've got information about the site. You know what's going to work in the site. You go to the nursery and you're going to buy the tree. First thing you're going to look at is how many roots are you getting? And in a lot of cases, the answer to that is not enough. So there are tables that will tell you for different size trees how big the minimum size of the root ball should be. So for example, if you're buying a balled and burlap tree and it's 3 inches in caliper, the diameter of the trunk is 3 inches at 12 inches above ground. And you're looking at the size of the root ball. If it's anything less than 32 inches in diameter, then that root ball is too small. You've lost too many of the roots. And same thing with when you're buying a tree that is grown in a container, a pot, same thing. So, for example, if you're looking at a 2-inch caliper tree and it's in a container, that container should be at least a 15-gallon size pot. And if you can't easily convert the size of a pot to how many gallons, think of a standard size garbage can as a 20-gallon container and go from there. Be careful of trees that are grown in containers like this. The roots grow out, they hit the inside of that container, and they start growing in a circle. And if you just pull that plant out of the pot and you stick it in the ground, those roots are going to continue to grow in a circle, and they're not going to reach out into the landscape. Might not be a problem in the first 10 years, but eventually, as the diameter of the roots gets bigger and bigger every year, and the diameter of the root collar gets bigger and bigger every year, eventually the tree will strangle itself. So when you're at the nursery, look for good trees. Look for properly sized root balls. Pay attention to the condition of the branches. If the tree has foliage on it, make sure that it's not wilted. Look really closely and buy high quality trees. There's plenty of nurseries that have really good stock, but you might have to do your homework. So, bottom line on tree planting, the most important part of tree planting is not digging the hole. The most important part of tree planting is proper tree selection. No matter how well you plant the tree, if it doesn't match the conditions of the site, it's not going to thrive and you'll be disappointed. So step number one is to know the site where you're going to plant the tree, learn about the soil, learn about the hardiness zone, pay attention to how much space you have, and be aware of pests and pathogens in your area. And step number two, be diligent when you go to shop for your plants. Know what is going to work before you go to the nursery. And then when you get to the nursery, make sure that you're buying high quality nursery stock. So consider the genus and the species and any potential problems that go along with that, especially, as I mentioned, pests and pathogens. That's why we're not planting any ashes anymore, and be really careful if you're buying crab apples. So bottom line is trees want to be vigorous. They want to be healthy. And if you plant a tree in a space where the site is conducive to that plant, excuse me, that tree will require less irrigation. It will require less fertilizers, less pesticides. It will be better equipped to ward off pests and pathogens. It will be better equipped to deal with decay if it gets injured. It'll cost you less money to maintain that tree. It will live longer and it will provide more of these benefits that we want in a symbiotic relationship with trees. So this is a really good book that will help you if you can find it. It's out of print. Unfortunately, you can find them used on eBay, but you'll probably pay more than $100 for them if you can find it. Good news is you can go to the website. Dr. Ed Gilman at the University of Florida maintains a website, and you can type in the characteristics of your site, and this website will give you a list of tree species that will do well in your area. So just type in Edward Gilman, University of Florida, and you'll see a great list of his publications and websites. So there you go. That's my story of trees.
That's good. Thank you for your story. One thing that I was thinking of when you were talking about going to the nursery is probably don't go to like the Walmart parking lot type places, right? When you go to a native nurse, when you go to a nursery that's in your area and they've been selecting trees for a long time, you're going to get that advice that you might need. And they should have already pre-selected the plants that should be good for your area, right?
Yes. And that's not to say you can't get a good plant, in Walmart or Lowe's, but chances are they're getting their stock from great distances. And even though the native area for red maple extends from Florida into Ontario, not all red maples are equal. So if you get a red maple that was grown in a nursery in Atlanta and it gets shipped up to Michigan, it's not going to be happy, right? You want to get a red maple that is is more suited for your native area and hardiness. So
We've
yeah,
got
be
Yeah.
diligent.
we've got a couple
And
of questions. Oh, I'm sorry. Pardon
oh
me.
yeah, go ahead.
I'm just thinking we have a couple of questions from the chat.
Good.
If you're okay, I one of them is how's sand cherry in our area? Do you have any idea? Does that even count?
Sand
That is
cherry.
sand cherry. Is that maybe that's a shrub?
It could be if I'm thinking of the species, yeah, it's um a shrub to a small tree.
Okay.
And as the name suggests, it kind of likes well-drained soils. Um, so if you happen to have a clay soil, it's probably not going to do as well. And typically, when you have these sandy, well-drained soils, um, they tend to be on the acidic side, and they tend to be somewhat sparse in nutrients. Sandy soils don't have very many what are known as cation exchange capacity.
Mhm.
All that is, it says for various types of soils, some soils attract nutrients and make them very available to roots, and others do not. And sandy soils are not very good at attracting nutrients and making them available to roots. And some trees take advantage of that. The pioneer species that go in after fires, um, especially on sandy soils like jack pine, um, are great on that. And I think sand cherry is probably one of those.
So if you have a really lousy site, jack pine is a tree you might want to consider.
Well, it depends on what your definition of lousy is. If lousy is very sandy and well drained, then go with jack pine.
Well, or like that urban soil that you showed us with
Yeah,
that was basically eroded next to a parking lot.
yeah,
Mhm.
yeah. It's kind of interesting that trees that do that as can be as well as can be expected in urban areas are those that have evolved in wet, swampy areas that have roots that are more prone to be at the surface.
Yeah.
And that's because in wet, swampy areas, the only oxygen that is available to the roots is in the very upper part of the soil. Well, if you take a tree, bald cypress is perfect example. If you plant that in a urban soil that's heavily compacted, the the root penetration is restricted by oxygen. And so if you have trees that have evolved with oxygen, with roots that are able to get the oxygen near the surface, they tend to do better in compacted soils, which is why silver maple is one that we see a lot in urban areas because of those high roots. Not very good for compatibility with concrete, but
Still.
that's
What
another
is?
problem. Yeah, exactly.
And Michelle asks, what about bare root trees? How can we assess their health?
Oh, I like bare root trees, but they're tricky to plant because you got to get them. They need to be dog after they go dormant. And then the nurseries will pack their bare roots with like wet sphagnum moss. And you need to get those in the ground in early spring. So, and they can do really well because you get a much higher proportion of the root system than you would in a balled and burlap tree. You get more roots for your buck. Um, but the window of opportunity to plant those is relatively small. When you do get them, you want to make sure that you're not planting them too deep. That's the biggest problem with planting trees that we see over and over again is that they're planted too deep. You want to make sure that the root collar, which is the base of the trunk and the top of the roots where the trunk swells, that wants to be at or slightly above the the grade that you're planting in. If that root collar is below the surrounding grade, those roots are going to suffer. So for bare root or any tree that you're going to plant, make sure that you get it at the right height. And that's determined by that root collar.
And one thing that I have found, if you're trying to plant a large area, several trees, and you go through like your conservation district to get these bare root trees, um, if you get those cloth bags, those cloth grow bags, they have you can grow them up over the summer where you have control and you can keep
Oh,
them really well watered. And then RJ was talking about that J rooting situation. Those root bags are really great at forming a really nice root ball that you can plant out in the fall. Have you found that too, RJ?
yeah. Yes, that's a really good idea. And the cool thing about the root bags is that when the roots get to the inside of the bag, they can perforate the bag. And if they stick through the openings in the bag, they're essentially air pruned. And so instead of growing around in a circle, they'll just grow more roots inside that bag. So that's a really good idea.
Yeah, and then you can rip them apart too before you put them in the ground. And
Yep, excellent.
are there any more questions, Marcia?
Actually, I just added what I believe is the Ed Gilman site to the chat.
Oh, good,
There's
excellent.
actually quite a few web pages where he's mentioned, so I'm hoping that this is close. Okay. I did have a final question here. You, the, I was really struck by the difference between the red oak and the pin oak in the cemetery. And it made me wonder if concrete vaults make any difference in the pH of the soil, but that's not really the question. How would you find out the trees' micronutrient requirements like that? I mean, we all know, I think, pretty much, we're all gardeners. We know about the value of nitrogen and, phosphorus and stuff. But the, you know, how would you know that pin oaks have trouble uh, with iron?
Yeah, yeah. So um, if you go to that Gilman site,
Okay.
um, if you type in, the pH range of your soil, it's going to tell you what species will do well within that pH range. And if
Okay.
we go back to that graphic that shows this guy here, um, pretty much if you want to know if your pin oak is going to work well, and you see that your soil is pH 7.5, you're going to know then what is going to be limiting factor is going to be iron. With red maples, they don't do very well in alkaline soils, and what their limiting factor is manganese.
Yeah.
So just by being familiar with this pH chart and knowing what your soil pH is going to tell you something about what your tree needs, or conversely, what it's not going to get.
Okay. Well, I'm going to ask you a favor.
Yes.
If just to make sure, if you wouldn't mind emailing me the link to that site. I'm not 100% sure I'm at the right spot. And
Okay.
I'd be happy to send it out to the participants.
Great. And if anybody else has questions or they want to track me down,
Mhm.
My email is very easy. It's R Laverne, Laverne at mtu.edu. And I'll include that, Marcia,
Okay.
with the link so you can
All
send that
right.
out.
That I've got. I can put that in the chat for sure.
Okay, good.
Okay.
All right. RJ, I have to tell you that I think that those trees do appreciate your hugs.
Well, read that article in the Washington Post and you'll see there was a research project done in Finland that kind of addresses that. Can you make friends with trees? And there's a benefit to doing that. Um,
Absolutely. Yeah.
and I don't know that the trees appreciate the hugs, but I think it's good for us.
Oh, I
I
have
think so. I think
here.
everyone here felt sorry for all those trees that you showed in the cities, right? We like feel empathy for them, but they're a living organism and they deserve to be respected, right?
Yeah, absolutely.
Okay, we have one last question.
Yes.
From that, I mean, not, there's a couple more, but we only have time for this one. From Bonnie, would like to hear a bit about mycorrhizal fungi in soil and their benefit to the tree and other plant growth. Anything that we can do to encourage that?
Pray. That's always good. Yeah, so don't get me going on mycorrhizae because we'll be here all day. But the short answer to that is that in the vast majority of soils, especially native soils, not disturbed soils, the spores for the mycorrhizae are already there. And the tree roots will seek them out, and the fungi will seek out the tree roots. You might go to nurseries and see products that are advertised as mycorrhizae that they suggest adding the mycorrhizae spores to the soil will be beneficial. And most research finds that that's not necessary,
Okay.
that the mycorrhizal spores are already there in the soil and they're ready to go.
Okay.
So they're fascinating organisms. And once you start geeking out on mushrooms, there's no turning back.
So, just one quick little follow-up to that, RJ. Let's say you are going to plant trees in pots and grow them up. Would it be wise then to get some soil from the place that they're going into so it could have some of that?
Absolutely. Instead of grabbing the plastic bag of potting soil from Lowe's, go out and dig up soil from the native forest. The fungal spores will be in there. The mycelium will be in there. You'll see the tiny little white threads, the hyphae that are seeking out the tree roots. And grab some native soil, and that's all you're going to need.
Great. Thank you.